Metamorphic thermodynamic equation and its applications in fossil energy formation. The two important factors that affect the metamorphic processes of fossil energy, coal or petroleum, are temperature and time. Vitrinite reflectance is used to objectively reflect the maturation of sedimentary organic matter. There are 3 temperature measurement methods without using vitrinite reflectance and 4 temperature calculating methods using vitrinite reflectance only. The vitrinite reflectance gradient of coal is generally lower than 0.06% per 100 meters in Plutonic metamorphism. The vitrinite reflectance gradient of the regional magmatic thermal metamorphic coal is higher up to 0.27-0.57% 100 m in Pingdingshan, China. W established a metamorphic thermodynamic equation for coal, MTEC, which contains ternary functions, temperature, time and vitrinite reflectance, so the third quantity can be found on the premise that there are any 2 known quantities. The results of ternary equations can be expressed in tabular methods, graphing methods, and analytical methods. The MTEC is chosen as the comparison value, and the temperature obtained through other calculating methods as the basic value. The relative error, the average relative error, and the standard deviation are used to verify the applicability of MTEC. A time-to-temperature ratio TT is designed to evaluate the relative contribution between the metamorphic temperature to the contribution of the extended time. There are 3 geological periods that can produce from low-rank coal, long flame coal, to high-rank coal, anthracite, in China. In the 3 coal-forming periods, the time-to-temperature ratio was TT1 under all vitrinite reflectance examined, and the effect of increasing the temperature by 1 degree Celsius was greater than that of extending the time by 1 million years, that is, the contribution of temperature was much greater than the contribution of extending time. During the same coal-forming period, with the increase of vitrinite reflectivity, the effect of temperature decreased significantly. At the same vitrinite reflectance, the significant effect of temperature decreases with the youth of coal-forming stage. The MTEC is more convenient and accurate than diagrams and is more in line with the scientific principles of coal metamorphism. Because it is very difficult to directly solve the paleogeological time using MTEC, an iterative algorithm is used to solve this problem. Control the iteration process with the difference between the new and previous values so that the iteration process does not run endlessly. The golden ratio value of 0.618 is used to optimize the relationship between the value of the new iteration and the value of the previous iteration. MTEC uses the calculated table to confirm that Xiao Xianming's simulation of vitrinite reflectance gradient and paleo-geothermal temperature gradient shows that 1. Vitrinite reflectance gradient is positively correlated with temperature gradient under fixed time and reflectance conditions. 2. In the case of fixed time and vitrinite reflectance gradient, the temperature gradient is negatively correlated with vitrinite reflectance. At the same time, it is also concluded that 3. In the case of fixed temperature gradient and vitrinite reflectance gradient, vitrinite reflectance gradient is negatively correlated with time. According to the measured static vitrinite reflectance and the corresponding burial depth of 26 coal samples in 4 groups of boreholes in the Huaibei coal field, the temperature of 26 samples was calculated by MTEC at a time of 137 million years. Vitrinite reflectance gradient from measured vitrinite reflectance and burial depth. The results showed that Taoyuan and Xuyuan both have vitrinite reflectance of 0.057% per 100 meters. They belong to Plutonic metamorphism. But Qidong and Linhuan have a vitrinite reflectance of 0.105% per 100 meters and 0.100% per 100 meters, respectively. They belong to regional magmatic metamorphism. But plotting all 22 T/0 ratios as vitrinite reflectance gradient versus temperature gradient can create a straight line with a slope of 56.3 degrees Celsius per %, which means that the temperature reflectance gradient ratio T/0, 50, and the metamorphism of Huaibei coal field is the Plutonic metamorphism. The metamorphic thermodynamic equation for petroleum, MTEP, has the same functional form as the metamorphic thermodynamic equation for coal, MTEC, due to the similarity of both metamorphisms. Therefore, MTEP and MTEC have 3 variables: temperature, time, and vitrinite reflectance, and have the exact same mathematic formation with different parameters. According to the dissimilarity of coal and petroleum, 4 parameters are determined to be completely different or partially different in the MTEP and MTEC2 equations. The measurement data from an exploratory well in Indonesia provides sufficient data to validate the MTEP. Judging by the error of the measured reflectance of the stationary body, it is more reasonable to use the temperature judgment in this book. For the 15 measurement points of the Tertiary period, the average relative error of temperature is less than 8.1% and the standard deviation of the relative error is less than 5.4%. For the 14 measurement points of the Mesozoic era, the average relative error of temperature is less than 3.1% and the standard deviation of the relative error is less than 2.2%. This book translates a well-known hypothesis, either an increase in temperature of 10 degrees Celsius or a doubling of the exposure time will double the rate of reaction, into a series of mathematical equations. And with the example of actual calculations, it is fully and beautifully demonstrated. For the 10 verification calculations of the Tertiary period, the average relative error of temperature is less than 5.7% and the standard deviation of the relative error is less than 0.87%. For the 9 verification calculations of the Mesozoic era, the average relative error of temperature is less than 8.3% and the standard deviation of the relative error is less than 0.13%. Excel and MATLAB are used for simple calculations and drawing figures. This important article is authored by the following scientists. Thank you for watching this video. Please subscribe to our channel BP International to watch more videos in the fields of science, technology and medicine.